Again, remember that del F just means the gradient of a function. It's a vector. And the vector field I want to give you. Here it is. I'll do a couple of these. Alright, let me copy this. X, Y, Z to the 4th. Comma. X squared, Z to the 4th. Comma. 4x squared, Y, Z, and slide. Y, Z cubed. 4x squared, Y, Z cubed. X squared Z to the 4th, X, Y, Z to the 4th. Can you determine whether or not the vector field is conservative? What's your problem solving strategy? What could you simply check? Find the curl, right?
Mm-hmm.
Find the curl of F, and if the curl of F is 0, the answer is yes. True? Hey, I do want to point out, some students prefer, for some reason, and it's fine. They go, can I do it like we did in the last lesson? And I go, what do you mean? They check, they thought of this as like a potential what? They go, can I look at this like the last lesson where that was maybe a potential fx, this was a potential fy, and this was a potential fz, and they go, can I just show 3 checks and show that, you know, if fxy must equal fyx, what were the other 2 pairs? fxz has to equal fzx, and thirdly, fyz must equal what? They go, can I go through that? And I go, sure, but do you recognize something? Isn't that like doing the curl?
Yeah.
Yeah, so whatever's easier for you. Most students decide, I'm just going to do the curl of vector field, and if it comes out to be 0, the answer is yes. If it doesn't come out to be 0 in terms of 0 vector, it's no. But I do have some students that really, they're like, I find this easier. And I go, okay. I mean, if you really think about it, it's probably the same amount of work. Okay. All right, let's get to work. IJK. DDX. Well, I better give some more room, huh? I want to make sure I can fit all those components in there. Alright, J, K, DDX, DDY, DDZ. Way over here. Okay. X, Y, Z to the 4th. X squared, Z to the 4th. And 4x squared, Y, Z. What's the curl of F? If it's 0, 0, 0, the answer is yes. We'll move on to letter B. If it's not, we can't do B. We can't do B. All right, wipe this out. What's the partial with respect to Y?
4x squared z cubed.
4x squared z cubed. Subtraction sign. That made the partial with respect to z.
4x squared z cubed.
4x squared z cubed. Hey! Maybe this is conservative. That's 0, isn't it? Try the middle component. Negative. What's partial with respect to x? 8x yz cubed. Minus, what's partial with respect to z? 8x yz cubed. Hey, this is looking pretty good so far. 8x
Well, it
y
should
cubed.
be 4x squared z cubed.
Ah. So this has come out to be what? I'm going to do this again. We did this times this, right, for this middle component. 8x yz cubed, then we took the partial with respect to z here, and we got what? Only 4x yz cubed. Should I keep going?
No.
Stop right here. Not conservative. Isn't that cool? F is not conservative. So we can't do B. That's impossible. You can't find a function such that F equals del F. It's impossible. F is not conservative. Great job. Hey, try another one. Oops. Well, we know we're going to do the curl. I can leave that up here. This is number 16. Y squared z cubed, y squared z cubed, comma, 2xy z cubed, and 3xy squared z squared. 3x y squared z squared. By the way, I've had some students, you know what they do first? Because you're all getting a curl right now, right? I've had students in the past where they're like, I'm just going to try to integrate everything the way we usually do. If I can create that function, I know I'm right. I'm like, you got a pretty good argument there, but this is an absolute what? This is an absolute way. Just get the curl of f. Show that 0. You know that vector field is conservative. All right. Run it out. I, J, K. dx, and dy, and d to z. Y squared z cubed. 2xy z cubed, and this last component is 3x squared y squared z squared. I want to double check I copied that correctly. 3x, no, that's just 3x, right? And that's 2xy z cubed, that's y squared z cubed. Okay, we're ready to roll. What do you get for the first component?
6xy z squared.
6x. Take the derivative of this with respect to x. Let me use this one to wipe that out. What's the partial of that with respect to x?
6xy z squared, right?
Oh wait, we're doing a derivative with respect to the x. Wouldn't the x go away?
Oh, you're doing it at x?
With respect to x, right? Because we'll do d dx of this, or delta delta x of that, and then we'll do the partial of that with respect to z.
Should we start with the
No,
front?
shouldn't start with the...
Oh, I like that. We don't have to start with the middle component. You're like, start with that first one.
Yeah.
Yeah, I agree. So very good. I'll wipe this out. Let's partial that with respect to y. 6x
y z squared.
y z squared minus,
6xy z squared.
and the derivative of that with respect to z is 6xy z squared. Is that 0?
Yep.
Cool.
Why did you do it with the respect to y on the first one?
Oh, great question. So for this one, I'm going to get the first component. I'll wipe out the first column. So I have to do that with respect to a y. And then I'm going to have to do that one with respect to a z. Good question. And I agree with everyone. When I'll start with that middle component, that's not the best idea. That can make us get confused. So I'll start right there. I'm going to make sure to start with that. Wipe out the first column and get the first component. Hey, the middle component, I'm going to put the negative. And what do you get?
Negative 3y squared z squared minus 3y squared z squared.
3y squared z squared minus 3y squared z squared, which is also 0, I'm agreeing. And how about this last component? So I'll wipe out that one.
2y cubed.
2y z cubed,
Subtract.
subtract 3, oh, 2y z cubed. What did we all get? 0? 0? 0? What's the answer? Is that vector field conservative?
Yes.
Yes. Yes. F is conservative. It's a conservative vector field. Was that okay with that? By the way, I know all that writing takes a while, so if you just want to write 0, 0, 0 in a test, that's totally fine. Now, let's move on to letter B. This is possible. It is definitely possible. We got to find f. Find the function such that vector field f is equal to the gradient of some function f. How do we do that? Derivative or integrals? Integrals. So we're going to integrate that with respect to x, put a plus. Integrate that with respect to y, put a plus. Integrate that with respect to z, put a plus. If you get any repeats, toss them. Don't forget about tossing any extra repeats that appear. So I'm going to get this thing started. It's funny because sometimes you're on a test and you start writing like, and you go, wait a minute. They want to what? Find the function. So I'm gonna write function of x, y, and z. Equals, all right, go ahead and do that. What's the integral of that with respect to x?
X.
Outstanding. Notice that when we just did an integral, an antiderivative. Okay. It's a partial antiderivative. What's the partial antiderivative of this with respect to y? 2xy squared over 2 z cubed. Or, that's the same as just what? Is that?
Yeah. So
Oh. No one notice that? That's a repeat. So leave the first one. I need to be careful when I say this. I say toss out repeats. People think you toss out a both. No, keep one of them. Keep the very first one. Bless you. We'll knock out any remaining ones. What do you get here? Partial root of x, or the antiderivative. Integrate this with respect to z. 3xy squared z cubed over 3. And these cancel. Is that a repeat?
yes, I'll repeat.
Another repeat. So this was a repeat. We got rid of it. This repeated. That's that same expression. Plus constant. This is it. So I'll write it again. Here's the function. Write it neatly. Okay, it's xy squared z cubed plus k. And you can always take time in a test to double check this by taking what? Take the partial with respect to x, you should get that. Take the partial with respect to y, you should get this. Right? That way you can check to see you didn't miss anything. Okay, can I extend this? I want to connect something that we did yesterday. I'm going to ask you to compute a line integral. Oh gosh, line integrals take time. Hold up though. Line integrals are pretty easy if the vector field is conservative. So when I was wondering, could you find, I'm just going to extend this. Can you evaluate f, ooh, no, I can now write del f. Del f dot dr for this vector field, okay? Where C is, I'm going to choose some kind of path. How about a line segment? C is a line segment from the point, how about, I'm going to make it some point in three-dimensional space. How about 2, 0, 4 to the point 3, 1, negative 2. I just chose 2 random points in three-dimensional space. You're like, really? That function can go through those points? Sure. I just picked x, y, and z points, right? The function exists at those. This should be real easy. Because by the fundamental theorem of line integrals, if the vector field is conservative, let's use it. What is this equal to? F of endpoint minus f of
Start point.
initial point. I mean, you could write it with the notation. I just think that's an easy way to state it. Take the function you just found, plug in the endpoint, plug in the initial point, and subtract them. We don't have to do all the dot product and all that. Isn't that cool?
We don't need the RT.
I know, because we don't need, because this is really, we could have found it, and then when we got R prime and T, then we would have done what? When we taken that vector field, we'd done F dot, that would have been directly. I'm going to put that over here. But it would have taken longer, wouldn't it? And I might have made an error doing all that stuff.
Just yesterday we had to do the tables with like the T
Yes!
and Y values. I just didn't know.
Great question. So in this case, because this was conservative, we're like, this is all we have to do. But if it wasn't conservative, like that very first one, you're right, I would have to use that vector field. And I would think of this as the integral of f composed of r of t. You and I would have had to create the r of t for that line segment. And then we would have done the dot product with r prime and t d. It would take longer, but this is going to be quick. Everyone, which one's the endpoint? Because the path went from here to here. So what's f of 3, 1, negative 2 minus f of 2, 0, 4. What do y'all get? Plug it in. You go right in there. What's 3 times 1 times negative 2? 3 times 1 squared times negative 2 cubed. Is that negative 24? Yeah? Okay. This looks easier to plug in because of the 0. What do you get? What do you get for your final answer? Reevaluated line. Isn't that cool? I just thought we could update a topic from yesterday. You go, well, what if it wasn't conservative? It's not so bad though. Especially with line segments. Because then with line segments, the r prime of t comes out really nice. Go over there? Hey, nice. Okay, so now we're going to talk about the divergence of f. So that's curl of f. Here's divergence of f. div. What's divergence of vector field f? It's going to look like the same formula. Del dot f. There you go. Put that over here. I'll erase all this stuff. Super job with this problem. Super job. What is divergence of vector field f? Divergence
There's a dot
of
product.
f is a dot product of del, there's del, with the vector field. So, curl of a vector field is a vector. What's divergence of a vector field?
Scalar.
Scalar. Maybe I should just say that a few times so you don't get confused. Curl of a vector field was a vector.